Hello, welcome to the video on wrapping up section 10.1 and 10.2, and also I'm going to cover 10.3 today. So if you're in class on Monday, which most of you were, we talked about the multiplication counting principle, permutations, and combinations. I believe B period didn't quite get the combinations, but I'm going to review all this again anyway. Starting with the multiplication counting principle, very easy. Excuse me. All you want to do is just multiply the number of ways each event can occur, and that will tell you all the ways those events can occur simultaneously. So we did that with the area code problem because if you had 3 digits to choose from, you had 3 choices for the first digit, then 2 for the second, and 1 for the third. Or for the deli example, you have 4 types of meat, 3 types of bread, total 12 sandwiches. We also extended this to the license plates problem, where you could have the first 3 are letters, the last 4 are numbers. If repetition was allowed, or sorry, if it wasn't allowed, we do 26, 25, 24, then 10, 9, 8, 7. But if repetition was allowed, they did 26, 26, 26, 10, 10, 10, 10. We did a telephone problem. If 01 cannot be the first digit, obviously you had 8 options for the first digit, and 10 for remaining digits. Factorial problem we talked about. Factorial is basically if you have a number and an exclamation point right next to it, you don't yell that number really loud. What you do instead is you count down to 1 to multiply it. And you can find this in the calculator under the Math and PRB menu. You could use a problem factorial for a problem like this one here, 8 movies. How many ways can you see those 8 movies? We talked about that. You do 8 factorial. We also talked about if you want to see one movie on Saturday and another movie on Sunday, there's 56 ways, because if you use the fundamental the multiplication counting principle, you have 8 for Saturday, 7 for Sunday, so you get 56 total. We also talked about permutation. N represents the total number of objects. R is how many of those objects you want to actually select. So instead of doing 8 times 7, we also could then 8p2. So like in this case with 9 baseball players, we could do 9p3 because you have 9 catcher. 9 people could be a catcher, 8 people could be pitcher, 7 people could be shortstop. And that's again in the calculator under the Math, then PRB menu. Not sure if I mentioned this all the classes, but 0 factorial just equals 1. So in this case, how many different ways can you complete all the assignments if you have 5 homework assignments to do? So obviously n's 5, and you're going to choose all 5 assignments to do. So if you do a permutation, you would get 120 in this case. Or you do 5 times 4 times 3 times 2 times 1 using the multiplication counting principle. We also talked about combination, and that's where I'm going to pick things up from. So did a quick recap. So N is still a total number of items. R is the number of items you want to select. And in this case, we use NCR in the calculator. So it's very similar to the permutation formula, except that you're dividing by this right here. So let's look at this card example. You got 52 playing cards, and we assume that most playing cards have 4 suits with 13 different cards in each suit. If or does not matter, because we use combination of or does not matter, how many different 7-card hands are possible? Okay. So N has to be 52, because I have 52 total cards. R is going to be 7, because we're selecting 7 cards. So we do 52C7, and that's it. So if I were to grab a calculator and work that out, 52, Math, PRB, NCR, 7, you should get 133,784, 560. So if anyone's ever played a 7-card stud, that's all the different hands that are possible. And order wouldn't matter, because if you had like 4 aces and 2 kings and a queen, it doesn't matter what order those cards came out in, that still has the same strength. So order would not matter for this. How many of these hands are all 7 cards of the same suit? Okay, so you want the same suit. Now if you think about it, first of all, you got to pick a suit. That'll be 4C1. Reason being is because you need to figure out, are we going to have diamonds, clubs, hearts, or spades? So 4C1, there'll be 4 ways to pick a suit. Then you need to pick 7 cards from that suit. How many cards do we have in each suit? 13. So 13C7. So if I work that out using the calculator, I get 1716. 1716 ways to pick 7 cards from a particular suit. So say I went with diamonds, and there's 13 diamonds, there's 1,716 ways I could pick 7 diamonds out of the 13 total diamonds. And in this case, we still have to multiply these two. That's just using the multiplication counting principle, because you have 4 ways to pick a suit, and then 1716 ways to pick 7 cards out of 13. So if I multiply that out, I should get 6864. A little more complicated, but that's how that one works. And so you can see what I did here. I want to find ways that event A and B can both occur. That's why I multiplied. But if I just want event A or event B, then I would add. So if I wanted a diamond or something else, let's say, I would add. Let's look at a few more examples, then we'll move on to probability. So you're taking a vacation with your family. Your family can visit as many as 5 different cities and 7 different attractions. Suppose you want to visit exactly 3 cities and 4 attractions. How many different trips are possible? Okay. So if you think about it, you want to do 5C3 times 7C4. Because you have 5 total cities, we'll want to choose 3 of them. 7 total attractions, but want to choose 4 of them. And so if you work out on the calculator, 5, math, PRB, NCR3, you get 10. And if I do repeat it, 7C4, I get 35. So it's 350 different trips are possible. But let's say I want to visit at least 8 locations. Then how many trips are possible? This is a little tricky. So I highlight the word at least. So clearly there are 12 locations total. 5 cities, 7 different attractions. And you want at least 8 locations. So definitely you want 12C8. Then you also want 12C9. because that would be 8 locations. That would be 9 locations. And then you keep adding a whole bunch. 12C10. Let me clear that up here. Plus 12C11. Plus 12C12. So you could choose. You could choose to see 8 locations. But you also could choose to see 9 locations. Because notice we didn't say the word exactly, we said at least. So you also have to look at all the ways you can see 9 locations. And all the ways you can see 10 locations. And 11 and 12. So if you work all that out, that's going to take a little bit of a while. Let me work on my calculator right now. You might want to work it out too, or pause the video. See if you get the same thing. So all that should be 495 plus 220 plus 66 plus 12 plus 1. And the reason why you would add them, not multiply them, because you can't see 8 locations, 9 locations simultaneously. That makes no sense, right? 8 locations is one scenario. Let's find how many ways that scenario could happen. 9 locations is another scenario. Let's see how many of those scenarios can happen. So a little different. You're not quite using the multiplication counting principle here. So if I add all this up, 495 plus 220 plus 66 plus 12 plus 1, I should get 794 for that one. And the last one. Restaurant offers 6 salad toppings. You can have up to 4 toppings. How many different toppings can you have? So you can have 0 toppings. You can have 1, 2, 3, or 4. So hopefully you can recognize that 6C0, 6C1, 6C2, 6C3, or 6C4. Add them all up. 1, 6, a little bit hard to do in my head. 15. I think the next one's going to be 20, if I'm not mistaken. 15. Add them up, and you should get 57. Now another way you could do this too, an alternative way. An alternative way would be the following. And let me make that a bracket. It's a little confusing. The parentheses and the C's look the same. What if you were to work that out? 2 to the 6th power 64 minus 6 plus 1. Oh, what do you know? 64 minus 7. We get 57. Why does this work? If you think about it, 2 to the 6 represents all possibilities. Because think about it. You have 6 toppings, right? Here's the first topping. Here's the second topping. Third, fourth, fifth, and sixth. And who knows what these toppings are? It could be like bacon bits, croutons, cucumbers, artichoke hearts, I don't know. But for each topping, you have 2 choices. Have it, or don't have it. Either you want it, or you don't want it. And so that's why there's a total of 64 ways. But what I did was, This is what we don't want, because that's 5 toppings right here, and that's 6 toppings right there. So I took that away from the total, leaving you with at least 4 toppings. I know it's a little confusing, but that's the best way I can explain it. I probably might have to come at it through a different angle. And of course, I will go over this with periods B, E, and F during block 2, because I'm not going to be here tomorrow. And G period, of course, I'll see you guys Wednesday. Looking at the time and how long this video has lasted, I'm going to forego 10.3. 10.3, in case you guys are curious, is about probability. I think that's probably best left for a video for you to watch before block 2. So I'll do the video on 10.3 tomorrow and then post that to our agenda. So you guys are only going to just do more of 10.2 tonight and then do practice of that tomorrow in class or for Wednesday during G period. But it's kind of cool because it kind of deals with like gambling and stuff like that. And for those who don't know, I do enjoy gambling. So you'll see a video on that tomorrow night. But for tonight, we'll just keep it with 10.1 and 10.2 because that's kind of a handful. All right, so I'm all done. And I'll see you guys either on Wednesday or Thursday. Goodbye.